I'll just pause the video here, the music here while I'm talking, because otherwise I'm just gonna confuse myself. But yeah, basically I'm working on a small motherboard for a ESP32 based, ESP home based air quality monitor. It'll be using a Nova SDS 011 to measure PM2.5 and PM10, so particle count. Um, yeah, I found out you can actually like put in JSON files for themes for KiCAD. It's really dope. But yeah, so I think this is Monokai. I actually can't remember. Right, so I'm making this air quality thing, and it's based on the Nova SDS 011, which is a $20 when you put in shipping, because like they vary between $15 and $20, but the thing that varies is the shipping. If anyone's wondering, yes, I did turn off the music for now. Right. So that's what it's doing for particle count. Then it's using a Sensor S8, the newest one, which is somewhere in between the industrial and the home, which is pretty good for CO2. I might add a spot for an SGP40 for total volatile organic, but those sensors are like $6, which I guess is fine when I'm paying 20 for those two other ones. Yeah, I'll probably add a spot for that. And then there's also going to be a SHT, what's it called? SHT31D, I think, for temperature and humidity. So, oh geez, this is going to be like, whew, 60, $80. Oh no, I already ordered the sensors, so those are like out of my mind. So it doesn't feel like that cost is on this board, but it will be. Oof. Yeah, I should just not think about that. I'll whoop, that has been scrubbed from my head. So yeah, I'm making a motherboard for this. The SGP. Yeah, let's open ESP Home. .io, and let me get Firefox up here, right in the middle. Oh god, I don't have Dark Reader in this. Oh no. Just a second. This is like a must-have. I've decided to start using Firefox when streaming, because that way I don't have to worry about what I'm logged into or not logged into and stuff like that. So yeah, don't have all the plugins I'm used to. Okay, now we have Dark Reader. It's gonna invert the images here, but oh well, fine with that. Right. So let's SDS 011. So that's that one. So this is a Nova PM sensor. It is fairly accurate. The Dutch whatever it's called bureau that does like in the Netherlands they have like at the time anyways they had 40 stations around the country that were like 20k euros per station, just for the equipment, measuring particle counts, and they wanted to try and see if they're like they tested a bunch of cheap sensors. So this is like $20, to see how accurate it was, because like their goal was to make a DIY kit that home users could make, and then they could get like a distributed network of sensors. So yeah, this was one of them, and they found it to be pretty accurate, and if it like accurate enough that it could be calibrated. They found it to be inaccurate in high humidity or low humidity. But again, so they recommend either ignoring the results in those cases or throwing or trying to calibrate it. The board will know relative humidity, so it should be able to do either. If I figure out how hard it is to calibrate. Not really sure what I'm going to reference to. I don't think we have particle count stations in Denmark. I actually never looked. Maybe we do. I doubt it. But yeah, so this is going to be one sensor. If we look here, it talks UART. So I'm actually not sure if this is like Modbus where you can have multiple on, but I doubt it. So yeah, so this is gonna need a bus. It's probably, I know on the ESP8266 you can just make multiples because it's software serial. On the ESP32 they use hardware serial. So let's see what's that doing on the 32. On the ESP32 it uses hardware UART units. Hardware UARTs. Okay, so it will do software UART as well. So I'll try and keep this over here. So right now, obviously for the programming and stuff, it'll use TXT0. So that's used for, and that's also what it uses for the logger. Okay, it has 3 UARTs, that's perfect. Because the other sensor that I'll be using is the S8. Where's that? Let's try again. No? Okay, they just called it the sensor then. Here, so this is so that was a laser-based particle counter. This is a laser-based CO2 meter. Right. Let's see. Yeah, and that is also UART. And then the SHT31. Oh, okay, 3XD. So it's like there's a 30 and a 31 and maybe a 32. I don't know. This is I2C. If I'm adding an SGP40, do they have the 40? No, I think the 40 might be a drop-in replacement. It does have some different registers, so maybe not, but we'll see. Because the SGP30 is end of life. It does this estimated CO2. I have it on a couple of sensors. It's rubbish. And see the CO2 sensor. Yeah. So also the SGP30 is 1.8 volts only, which is annoying. The SGP40 is pin compatible, but up to 3.3 volt, which is nice. Cool. Yeah, so that'll work out perfectly. Let's look at the UART component here. Where? Okay, so they don't have a reference for that. Then let's go in here and look. UART 1. No. Pins. Where's the pins? Pin description. Whoop. TXT0 and RXT0 is actually thoughtfully laid out, but none of the others. TXT. So that's UART 1 on 17 and 18. And UART 2 on somewhere. So let's lay out UART 1 first. Sticking to this kind of labeling where it's upstream RX and downstream TX. Then I can just, so this is downstream, this would be the upstream. So upstream RX, UART 0. So I think I'll turn on some music and yeah, I'll keep going. I can probably see the YouTube chat easier, so if anyone has questions, just ask them there, because that's on my phone next to me in a stand. So yeah, I'll get started. I will turn off the datasheet so that you can actually see what I'm doing. So just know that I'm looking up these pins in the datasheet. I'll quickly bring up the... Okay, so I was actually mistaken because I didn't decide to look at the header, and the header is name, pin number, so this is the numbering on the module, and then the type. So I was looking at these numbers, I should be looking at these out here. So let's find U1. Oh no, underscore, okay, txt. So that is GPIO 10 and GPIO 9. Is it labeled differently here? Yeah, it is. Whoops. No. No KiCAD. I want to select them. Thank you. SHG and SWP. And that's probably won't be able to see it, but we can do that. So this is the upstream transmit, which would be SWP, and upstream RX, which would be SHD. Yep, cool, okay. Back in something that makes sense. Here we go, here's the 2 transmit on IO 17, RX on 18. No, RX on 16. There we go. Cool, so now I have my 3 UARTs, which are hardware, so they have to be what they are. Let's get this food. Right, so if we look at reset here, if we go to here. Don't have to solder the bottom pad, just make sure you use the right amount of solder if you do. To make sure it powers up as advised, it is advised to use an RC circuit on the enable pin. And it says to be determined, or to be TBD here, to be determined. They really want you to experiment with it. They do say that it's usually a 10k pull-up on a 1 microfarad capacitor, which gives a time constant of 10e3 times 1e minus 6, which is 10 milliseconds. Wow, okay. But yeah, that's basically just to ensure that it enables after the IO line is pulled out. And actually some boards have issues with that because they don't have that. They don't have the capacitor basically. But yeah, so then we have the auto reset circuit down here. I will organize the schematic better once I have a feel for where everything goes. But yeah, so up here, it's a bummer I didn't do them to KLC, so it doesn't really matter. But I added this component here, which is a Murata mains power supply module. It's only 25 point something by 25 point something millimeters. Cubed, possibly? Right, so by the way, the reason we're using 5 volts here and the regulator is because the sensor's needed. I just want the data sheet, doesn't matter where I live. Thank you. Give me a couple of seconds. Got it here from Mouser. Okay, so this little thing, actually really nice. It's a 5 watt power supply, so like 5 volts, 1 amp, which is ridiculous. Like I was gonna put on a VTX 21401. What's the voltage? 105. Which is this one, because I have had this for like 6 years. This is a 1 watt, and it's about the same size. And this one needs an external noise EMI cap and fuse. So yeah, yeah, this is like a few millimeters smaller. It's really amazing what they can do with the same space here, because this does not need any external components. What was the height of it? Have that down here. Yeah, it's actually lower. It's 2 millimeters lower. You can't see that, but it's a 16.3. The other one was 18 point something. Anyways, back to the layout. And I will turn off this so that I don't accidentally start working down here in the corner and you can't see it. Never forget the CC resistors on a USB-C plug. If you do, you will cry. And never use 1, always use 2, or it might not work in both orientations. This signals to the host port that this is a device port. Whoops. Can I not G that? Yeah. G to drag in KiCAD. I think I'll drag this down here, because we will have to cross these over regardless. I always like to go out 2. sure why I did it like that. Oh, come on. Go. Okay, that would be the USB. This is an isolated mains power supply. So this side over here is actually isolated from the mains, which is nice. So I have a diode, Sharky diode in line here. Haven't decided on which one yet. It just has to. I want it to be SMD for print. Actually, let's just sign that. Diode SMD, and we want it to be SMD. Let's leave options for it to be SMC as well. Yeah. I don't want it to be larger than that because we don't need that much. Yeah, we don't need that much. It gets a bit hard to find 1 amp diodes in that size, but like an SMC size. I don't actually know what the modules use. It's actually, they have the data sheet here. Power requirement. Woo! Holy, yeah, okay, then the dinky little 1 watt supply I had would not even drive that, because it has to be more than 1 watt. Holy! Okay. So 200 milliamps just for that. I do not hope the other sensor uses as much. Sensor S8. It's not the residential, it's the 0053. Oh, they're using the same picture for all of them. Do they have the table down here? Ah, 53 there. Low power. Nice. So it's actually low power. Documents. Just call it data sheet. I mean, really shouldn't be going under 400, realistically, because, well, I'm measuring inside, and if I somehow manage to, well, I need a lot of lamps if I don't want to go below ambient CO2 level. But yeah, okay, so power, that's what I was looking for. Ooh. So we're at 500 milliamps now, boys. Oh, that's a big oof. Yeah, we need 1 amp. Good thing that's a 5 watt power supply. Oh, dang. Oh, this is actually Modbus. Note 5. Okay, so it's either UART or Modbus, and the ESP home implementation uses UART. And it looks like Modbus would be over 485. Whatever. Yeah, there's some sort of combined stuff here. Okay. Right. We have enough power, barely. Well, we have plenty of power, to be honest. Because that was just peak, so I'm guessing when it's firing the laser. With an average of like 38. So I'm guessing it's pulsing the laser or something. Should be enough, but we definitely do need to find... Okay, so now we actually do need to find a 1 amp Schottky diode with not terrible leakage. Passive components. Nope. Semiconductors. Sweet semiconductors. And we want to look for diodes. Schottky diodes. Okay, that's redundant. We don't need to specify that. Let's just specify here. Damn, okay. Guess I'm an old man, because, okay, that is an SMB. Do they have any SMCs that... Wow. What's the reverse leakage? Pretty bad. And what voltage is that rated at? This was the... B340. So up here. That's okay. I mean, reverse voltage will never be more than... Wow, no, never mind. That's like stupidly low. Okay, so in this, you can see what I'm looking at. God damn it. Well, I'm looking at Firefox. I just went through Mouser, looked up diodes, and found this. So the way these are used... Now I have to turn off again, that's why I remembered. So the way these are used is we have one up here. Here, let's just... So they're just to prevent backfeeding from one power supply to another. So here's power supply 1, here's power supply 2. But they won't be perfectly matched. So if it's hooked up to, let's say this is hooked up to the mains power supply, and you then also connect it to USB, USB is probably going to be lower. So if you didn't have these diodes, mains would just feed into the computer, and most computers will be fine. They probably have reverse protection in their motherboards, but some don't. And yeah, so like say the computer, you're using a long cable or whatever, the cable's not really that great, so it has thin conductors. So by the time you get here, you're probably looking at 4.8 volts. While the power supply here is like right here, so it's probably 5 or 5.1 volts or something like that. So yeah, that would be a 0.3, 0.4, let's say half a volt of difference between this point and this point. But yeah, with the diode, they drop some voltage, so it'll be, let's just say they drop the same. They don't quite. Oh yeah, they should, it's current based. Regardless, let's say they drop the same. So yeah, this just makes it basically sources current from the supply with the highest voltage. And I don't like that. God damn it, that distracted me. Right, so it just makes sure that this is consuming from the supply with the highest voltage. And if the supply drops under current, consumption, well, it'll just pull from the other one. But yeah, actually, considering if I need this, because I will never have it. Yeah, let's just in case you have some sort of weirdly high voltage USB port. Yeah, so that's that. So what I remembered was that if we go back and look at the data sheet here, so this is the reverse current in microamps based on the reverse voltage. Wow, this is a high voltage hotkey for what it is. Maybe, I actually am not sure. Oh, I was confused. This one had the same labels, but it's for we're looking at this one. Okay, cool. We're probably gonna be at a room temp. Probably not gonna get much better than that. So we're looking at, so I said half a volt. So like we're at 10 here, 5, 1. We're like down here. It's fairly linear. So let's say we're like down here. So yeah, that'll be a microamp or 2. That's like, it's 2 up here. So yeah, 1.5 microamps. Wow, that is a lot better than I expected. I'll still leave room for a D, but let's just put that part number on there. So as you can see here, that is an SMC. Put the pod number in here. Cool. Cool, let's look at the datasheet for this one, and it's a typical connection diagram. We are not going to be using the voltage regulator here. So in that case, it is fine running off of 3.3 volts. I'm assuming VIO in this case is also this, because, well... Oh, it's reset. Never mind. I'm dead. Okay, cool. So in that case, it wants VDD and reg in to be combined. I'm guessing it still needs 5 volt for V-bus. I will have to check, but this does not need to be powered up. But 3 volt will be present. I'll have to check if this is allowable. So let me just show you what I'm looking at the data sheet. So here is just the power it wants. I still have to add these. But I think I'll add a D-band square at some point. It wants 100. nanofarads and a 4.7. There we go. So it wants a set of these for each power pin, so let's do that. Do I want to lazy it out and just do 2 because bio and these are tied together. Oh, they're all right next to each other. Two will do fine. Like they'll literally be connected to each other. Which I guess is what they want to avoid, but like, no. Fuck it. I will consider this 1 pin. Yeah. This and this. That will be 1 pin. So here's my debounce. There is the ever continuing discussion if you should connect shield to this or not. I think generally, well, it depends, but like on devices you probably shouldn't. You should probably do it through like a an RC network, maybe, but that's like EMI stuff, so magic. Okay, let's look what it wants for. There's charger stuff? I don't think this one does. I wanted to go with the 20 pin version, but it doesn't have DTR, so I had to go with the 24 pin version. Right, let's add a USB, no, what is it called? ESD, USB. Yeah, there you go, USB LC6. And I will not be... Yeah. Because I'm just doing the dumb CC stuff, so you can do smart CC to do current negotiation. But yeah, the reason you have these CC resistors is because the USB-C ports are symmetric. So the host can be a USB-C port and the device can be a USB-C port. So you want to make sure that if someone takes well, I'm saying that as if that's wrong, but it isn't. So like if you have two, host this the wrong way. If you have two powered devices or power supplying devices, like a monitor and a desktop, because you won't be charging a desktop from a monitor, but some USB-C monitors will be able to charge the laptops. You have to make sure that they aren't both trying to power the bus. So you negotiate that over the CC lines, amongst other things. If you just have a simple device and you put 5K1 resistors on there, it'll identify it as a simple device. So you have to do that. If you don't, you won't get power when you're on a USB C host, so with a C2C cable. Old school A cables, well, I mean, those old school ports always have power on them, so it won't impact you in that case, but yeah. If you do have power negotiation, like actual clever power negotiation, this would have been hooked up to some sort of pin on the IC, in which case you do care about ESD protecting it. I don't, because because they're just connected to resistors. So, only thing to connect or to do is ESD protection on would be D- and D+. I said, while looking at the datasheet, which also wants it on beat bus. Fun. Okay, well, in that case, let's go for the ESP RC6 2SC 4SC6. My bad. I thought it was SC2 and SC4. Nope. Okay, as you can see, it has 4. So we'll be wasting one, but okay. Let's put some names on these. D-. That way we can also route them differentially when we get to that point. D+. So I'll probably end up swapping this around later when I figure out how it routes best. But I'd imagine if we look at the footprint here, you cannot see because I am a dirt face. So what I was saying earlier I had it's the same package, but it only has half of the diodes in it, so it's a pass-through. Instead, here you use all 4 pins for different I/O. Actually, I might not have had the data sheet up at that point, who knows. Anyways, we were looking at the pin out here. So D- and D+ will be routed close, and have a ground would be 2. So yeah, I think I will route USB on the underside, pop them up in BS, maybe here and here for the SD protection, and then continue them on the other side. Yeah, so 1 and 2. Oh, sorry, 1 and 3. And then let's replace this with... Oh, we can actually use the other one just fine. Because VBus will be protected because it does have like a rail protection in it. The 2SC is fine. So in that case, you can see here. We'll do this because then the chip is made to like actually route it through. And then instead of the label we had up here, we'll do a VBus PAL thing. And this will be a HRO, LCC, HRO, Type C, I forgot, it's like 31 or something. Type 31, no, 31, Type C, I don't remember. Apparently I kind of remember. So it's Type C, 31, and then I think it's the 12 I'm after. 14 is the mid mount, right? Yeah. So it's 12 I'm after. This is a great USB-C connector if you're just doing USB 2 stuff. Because it shaves off all the unnecessary pins. And it's cheap. So yeah, you can see it just... God damn it. Is there some sort of plugin so it auto switches? Here's the the connector. HRO Type C 31 M12 with some dashes in between. Right, so yeah, it gives you your ground pins on both sides because it's symmetric. Good. Well, yeah, here on both the A and B side. Your SPU pins, which are like, what is it stands for? It's like, whatever. It's like if it's an audio mode or whatever, or stuff like that, it goes over those pins. I say whatever a lot. I'll try and stop. And then you have your CC pins and your data pins. So yeah, you don't really need much more when you're doing USB 2, or rather when you're not doing USB 3. But yeah, and it's in KiCAD as well, so that's really nice. So HRO, they don't have their brand in the names. It's just C31M12. That way it is not a huge name that spills out over, and then we can put our VBus pad right here. Should be getting close to routing. I've never laid out this 2102 chip before, so that's a bit new to me. I don't know why it's... Okay, this is specifically for battery stuff, so let's see if they have something... Bus power connection diagram for USB pins. D minus, D plus, VREG, and VBus. Do they have a self-power connection diagram? Right, so what were those? This one. So it was 24, 22K1. It wants 3.3 volts on that pin, that's why. Okay, makes sense. Doesn't make sense is that is a terribly annoying value. For reference, I have this. So it wants what? 47K5 and 22K1. I know I'm running an E12 series here, which is pretty low, like E24, E96 might be better, but I don't have room for resistors. I have a box. So 40K, 47K and 22K should probably do. Let's confirm. We want 3.3 volts on that. That was 3.4 if it was perfect. So let's look. I hate this. This is what I was showing you. Oh well, what I was talking about. So this is the self-powered mode. It wants 3.3 volts on this pin. Right. And these are the resistors I have. These are no longer orange, but I will change that later. These were ones I considered ordering, and I have ordered them, and I have them now. So yeah, but I have 47K and I have 22K. So let's try and do the. So it's R2 over R2 plus R1 times the input voltage. So R2 would be 47K in this case. 47K or 47 doesn't matter. It's a ratio. So 47 over 47 plus 22 times 5. So let's actually do the ones they want. So that was 47.5. Was 22.1. Yeah, this 6.5 millivolts lower if I use my resistor values, which is good. That's the right side. So I'll just use that. Like, why? I guess because if you're using these resistors, you know they're in like a 1% or 0.1% precision range. So you don't have to specify it. Well, in theory, if you follow the accuracy requirements of the appropriate E series. Right, so the other thing I was talking about with this here on this diode here on V-bus, this ESD diode here on V-bus, it has this in here, which is a Schottky diode. No, a Zener diode. But that's, I mean, it's good enough for me. I love symbols that decide, yeah, let's put the labels right where you have something connecting. Makes sense. Okay, so this is another thing that goes in a separate box once I'm done. What more do I need? Right, I need to check if this needs anything else. Like, maybe I need to deal with these. So it is regulators. Regulator is not used, and that is indeed what we have done. Let's see what VIO wants. Here. So that's not a problem. VBus can max be VIO plus 2.5, so even if we didn't do this, we'd be fine. Oh, that's probably why they're doing it. Okay. I mean, this would be off because I have it from before the diode, but that's fine because this is apparently used to detect when it's connected to a bus. So that's actually where you do want it. So here, I'll just quickly show. So because I'm taking this from before the diode here, if it's powered from the wall only, this will hopefully, yeah, I'll actually add a pull down resistor. Actually, I have to add the, this is getting messy. Right, 47K. 22K. Let's go 2 up from that, and then let's put this down here. Cool. That'll also actually, this is great. So that'll also protect against reverse leakage if I do get like a worse diode, or if it's too much. Because the thing with Schottky diodes is they have more reverse leakage. So a problem you can run into is that current will leak back through here and charge up the pin here, and then if the leakage into that pin is not high enough, that voltage can charge up high enough that this will be this will consider itself connected to a power supply. And if it's using this for detecting if it's connected to a USB port or not, it shouldn't have a high signal if the USB isn't present. So this should provide adequate leakage current to combat any leakage up here. Hopefully, we'll see. If nothing else, it leaves the pad there for it. So yeah, I think I can. Do that. We'll just be nasty and do that. Don't feel like rap right now. Cool. Let's see if there are any more requirements for the hookup. So I don't think they have any more examples because we were on self-powered. So let's go for the pins. This is not really what I'm looking for. I'm looking for a pin description. Here. Digital input. Ring indicator control input active low. What in the world does that mean? See, I'm not old enough to have dealt with serials, so I don't know if ring indicators is a totally common thing that everyone knows about, but I don't. See, this is a 5-volt signal, and this pin indicates a USB network connection. No, not a 5-volt signal, a high signal. Because as you actually recommend in your own in your own data sheet, like a few pages earlier, well, a lot of pages earlier, you need to like put a resistor divider in. But okay, fine. Interesting, so you can wake up your computer with this, I guess. Am I gonna put LEDs on this? Maybe. I guess it is nice to be able to see. Oops. So the question is it active high or active low? Ah, nice, KiCAD has been covered. Active low. So let's go look at my green and red. So the green one would be this. And this is my red. Okay, well, since it has such a long name anyways, let's... No. That's not what I wanted to copy. Man, that's terrible. Does it have a shorter name? Is it just me who's been dumb and copied like 2 different names? No, they just decided they wanted everything in the name. Cool. Cool. How much of this is relevant? 1921, Cersei. This probably is tape and reel. Maybe not. Who knows? They usually have. Yeah, here, label explanation. No, that is this. Okay. So they do not have an explanation of that name. Neither do I.
Told me before you leave, if there's only one thing you remember from me, child, when you're out on your own, a million miles from home.
Okay, so forward voltage is at 1 milliamp. Yeah, this is programming, so this should be. But on the other hand, I don't really want to. 10 milliamps, pretty bright. 1 milliamp. Sure, let's run it at 10 milliamps. So then we'll have a forward voltage of, what is that? What is that? So there's a 4 drop, so there's a 2 drop to there. Okay, it's 1.8 volts. I'm too lazy to actually do it myself, so I just do this because it also actually recommends. So 1.8 volts and decide the lead current 10. I have 1. So exactly 150. And curiously enough, the recommended standard resistor is 150. Cool. That doesn't happen too often. So
I'm on my own, broken alone. I feel the rain crashing down all around this empty town. I'm searching for the lost and found, but you don't care, you're unaware. Keep moving like the scars aren't even there.
let's see what the drop off the green one is. I did not show you that on the previous one, so let me show you here. So we have the green one. This is a less nice data sheet. The previous data sheet. Here, let me show you this other one. So we want 10 milliamp forward current because we look here 10 milliamps, which would be, I guess, this one here. Actually, they actually mark that like with a tick, but okay, sure, whatever. So yeah, then we were at 10, 20, 30, 40, 50% luminous intensity, which is fine by me. Which is probably actually like way bright. What's the okay, I can't go over 70 degrees. As if I'm gonna do that. What is the luminous intensity? Chip rank. Boy. I guess mine's an 8.2. Thank God I copied the entire name. That's terrible. Damn, there's a lot of difference. Okay. So I'll be at 50% of that. And I have no clue if that's a lot. For an indicator LED, fine by me. Okay, let's look at the green one. So that's this one. We want... Let's try and match 20 MCDs. Let's try and match that. So green is... So at 10 milliamps... Oh, actually, let's do it the other way. So we want 50% luminous intensity, and we're at the green one, so we want 15 milliamps here. Actually, no, I'm getting ahead of myself here. We want 20 MCD. So what is this rated at? This is the QTLP 600C4 TR. C4. Yeah, this one. Ooh, good, that is. That's not great. So we want all of it. So we want 20 milliamps. So that makes finding the forward voltage a bit easier. It's 2.1. There we go. And then we need a 68 ohm. Do I have that? I mean, I'm making an order for this anyways, but I do. I have a lot. So for the green one, that should be 68. Now I have to decide what do I want for the transmit. So right now I'm receiving with red and transmitting with green. Yeah, I like that. Don't know why. I do not want this green piece in between because that is more for me to select. I think I can group them, but yeah, doesn't need to be there. Because I have decided I want these to be turned this way. I guess that's fine. It's not great. This will not be my prettiest schematic. That's fine. Let's see what suspend does. Let me show you what I just did, because I am bad at switching overlays. So yeah, I just... Well, which I guess is fine, because this time I spent actually mostly data sheets. Yeah. So like right now I just did that. So the green one will need a 68 ohm resistor. Put the part number there just because, for completeness sake. Can I put it in like a hidden field? I could. I don't want to. Right, it's a 603. You can do all of this later. Sometimes I do it while going. I like to have these hand solder footprints because the LEDs are like castellated pins, which are already annoying to solder. So the hand solder. So here, if you look at the pads here compared to, see, whoops, see they're just a bit longer, and actually makes a huge difference. Let's just make sure that this RS and wake up pin doesn't need anything special. So we have suspend and suspend active low, 15 and 17. Okay, so those are outputs. In case I was curious whether or not ESP was suspended. That's nice to know. I have no clue what this ring indicator stuff is. And the last one would be RS485, because I think the wake up pin here was in order to turn on the PC, and it is active low. Is it internally pulled up? I hope so. Pin 12. Digital output.
Let's take it slow. Where you go, I go too. And if you hit the bottom, I'm going down with you. Let's take it slow. Who cares where we gotta be? You know you'll have a good time wherever you're with me. Let's take it.
Right now, I am looking through the datasheet to see if the wake up pin is internally pulled up.
You ask me how we got
Yeah, here.
You don't know how. You say we're taking on water, yeah, we're sinking now. You're looking all concerned, like we're gonna drown. But we both know how to swim, no worries, let's flow for now. Let's take it slow. Where you go, I go too. And if you hit the bottom, I'm going down with you. Let's take it slow. Who cares where we gotta be? You know you'll have a good time wherever you're with me. Let's take it.
I wanted to read more. I can read that application note. But that, to me, well, yeah, internal pull-ups, very weak though. Like, what did they say? They said like 10 microamps.
I know I'm not easy.
Whoops, that's pages. I was looking for this.
And there are days I hate you, but baby, you're still mine.
Yeah. Typical 20 microamps. Damn. Yeah, okay. I think that's it for that. What more do I need? I need to figure out what this RI is. I mean, it should be pulled up, but what is it? Just because I'm curious. Ring. Yeah, so that's an RS232 thing. Ah, okay, there's literally like phone stuff. Okay. Not something I need to be worried about. I'll wait with populating that until I have gone through this. So this is JTAG. Do I want JTAG? Sure. It's a 4-pin interface. Nice. Then I can use my... Oh, right. That O2 or JTAG. Is there a nice JTAG? No. Should be a 6-pin JTAG. I mean, okay, then we'll just use an 01 XO3, sorry, 02 XO3. Let's just see if there's some sort of de facto standard pin out for 6-pin JTAG. Not really, they all seem to be 10 pins. Well, spin our own then. So, this down here is what I'm doing right now. This is handled, I think, yeah. And we need deep bouncing, and they want 10 macro. What do I have? That's squeezing it a bit, but it's doable. I also have these. Let me check how many I have. Not mad. 60. Ooh, a lot. And for the 57, not that many. I think that makes up my mind. I will be using... Here, let me see, what do we have for 100 nano, 603, 55. Not that many. Need to buy some of those. Shouldn't be too expensive. I think I need to get the same part number so I don't have to... Yeah, do they have those actually? They might be... unstopped. Bummer. So I want 100 volt X7R. I also want to try and match it so I don't have to keep two different items. 100 volt, 0.1 off, 10% X7R. $18. Whew. Okay. Down from 300,000 to 18. Quite impressive search engine actually. Ooh, from Samsung. Are there any Murata nearby? Down here there is, so then that would be the same. What was this? GCM? I think maybe this might be a replacement. How much more expensive are those if I buy 100? So that would be €8 versus 2.5. Yeah, it's gonna be the Samsung. You know what? Which did I say? 55. I have like 20 or 30 stored. So like, oh wait, no, I won't. This is a very common cap. I'll add 100. Yay! I'm over €50 now. Barely. Oh, actually, I'm not. It's because I'm not in Brave right now. Let me just go add that to my master shopping, just so I don't forget. I do not want to add 1,000. Okay, let's get back to KiCAD. So I could be naughty and just not do 10 microfarad as they ask, but I'll be slightly less naughty and do this. Then they are almost at 10. I mean, with the tolerance that are on caps, pretty much spot on. Put this box away. Okay. Let's get back to room. Wow, that's actually nice and simple. It doesn't want anything else. Okay. I'm never gonna do JTAG. Am I really gonna break it out? Oh yes. Like if I don't break this out, I will for some reason need it. I don't have a JTAG programmer, but somehow like I will need it and then I won't have it. So yeah. Now that I am breaking it out, I will never need it. It is just the way it is. Do I have 150 ohms? No. I have 180. Guess I need to get that. I do have 8 100 ohm resistors, but if I remember right, they're like huge. So I'll do this with 120 ohms. I'll put them in as they should be. Let's match this with the ISP pin out. Yeah, actually, let's just put in ISP 6. And then let's call it JTAG 6. Now I have to figure out what the JTAG pins, like what they mean so that they can be sort of logical. MTMS means here, let's go back to the datasheet. Let's bring this up over here at the end. Let's do the duplicate it and search for MTMS. It is not mentioned. Guess I'll have to actually Google it. Oh, so they think the M means something. Alright, so I am looking at Wiki. Test mode select. MTDI is test data in. Okay, so I will do. Ooh, this is a good one. I actually recognize. Oh, I'm having a hard time not singing along.
Someone to clean up and tame. Oh, some things never change, never change.
I'm not going to use resist network for this just because it's another SKU I don't want to hold on to. Here I wish I could select all of them and edit, but I thought they added something like that. Maybe it's not E. Or maybe it doesn't apply to these for some reason. This is the nightlies, by the way. Okay. And then I will add some labels to these, and I will call them MTMS, MTDI, MTCCO, so I'm guessing that's the clock, and MTDO. So this would be select, which I am putting on reset because that is actually usually chip select when you're using SPI. It's not with the ISP though, but yeah. Data out, master and slave out. Yeah, this would be the slave. Cool. So, again, I forgot to remove that, but yeah, there you go. So this is just what I did. I was fussing about with these for a bit. This way, if I put on accidentally an ISP programmer, I won't fry it because the power pins are in the same spots. And I won't be able to put it on backwards because it'll be a
wanna take it all in, I'm falling. The cityscape by night, wanna catch in my photos. Where you go, every corner twice as bright. They'll be my treasures forever. When I can't hold you tight, I'll see the Stockholm light.
It's like a Poco pin push probe called the Tag Connect. The 6-pin version is the TC30, and I picked the one without legs because it takes up less space. Right. This then hooks up MTMS, goes to IO14. Whoops. And TCK goes to IO13.
But if in time it's yesterday, your picture's gonna bring it home to me again. The world is
Whoops.
waiting up. The world is waiting half a step beyond our door. Oh, and if it's not enough, I wanna see the stuff the world has got in store.
What was the next one? MTMS. What have I done? MTMS and MTCK. MTDI. 12. And output on 14. Nice. Mirror it around X, move it over here. Yeah, let's make a... Let's migrate on. So let's say ESP32. That's annoying. So that is my decoupling. I will put Montrous and DTR. It's not strictly following the right voltages for either standards, so I won't name it as such. Auto. Good. Because all of the pins on the right side, I can't really, like, if boot had been on the, oh, whoops. Oh, right. Yeah, because boot is on the right side, it would be awkward to pull a wire all the way over there, so I'll do it with labels. Boop, 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 boop. Alright, I'm using this transistor, by the way, because I have it. It's what they call digital transistors, that brand specifically. It's just a pre-biased transistor. It has the resistor network inside, which just makes them nice for like switching stuff, because yeah, you don't have to worry about them. Also, this is a 2-in-1 package, so like, yeah. Has everything there, don't need any resistors, nothing, tiny, it's great. Let's bit the ESP protection down here. Hopefully. Will this fit? Yep, nice. Well, damn, that almost looks good. So the reason I put this over here was that I hopefully could have connected up nicely, but nope. Not really. Maybe if I... It's not terrible. That would be. So if we take this, basically I want to move this one closer.
Feel uninvited. Left you home in West LA. I'm not excited. So uninspired. On my way to play the bay while you're alone. This girl's a wonder. She loves me, yeah, she needs to know I love her. I wonder if we'll make it through this summer. Just wanna touch like back when we were younger. Yeah. Why don't you love me, love me, love me?
Oh, whoops. This would. Yeah, so these would need to be.
Why don't you love me, love me, love me? Touch me, touch me, touch me no more. Love me, love me, love me. Touch me, touch me, touch me.
Hmm.
Love me, love me, love me.
So that's right on there. Okay, so I'll use that as a perpendicular line. Uh, okay, I've been staring at something obvious for ages.
Why don't you love me, love me, love me? Touch me, touch me, touch me no more. Why don't you love me, love me, love me? Touch me, touch me, touch me no more. Love me, love me, love me. Touch me, touch me, touch me. Love me, love me, love me.
Yep, that should do. Then we just need
I can't help myself, you're a drug to me.
the UART connectors for the sensors, and then possibly some I2C sensors. I think I will. I should stream more. I feel like I'm pressuring myself to to make the data sheet prettier, because I wouldn't have done this. Like, usually this is what I do when I consider a design done. Like when I've had a prototype made and stuff. But because I'm streaming, I'm actually just doing it while going. Yeah, that makes sense to go with the power stuff, doesn't it? Is that Isabel? What's that? So while you can see the overlay in the bottom corner, I can't. So okay, that's just something random. Ooh, that one's good.
I live inside my own world of make-believe. Kids scream,
Sure, let's just
cradles, profanities.
put this down there.
I see the world through
Okay, so we have our power supply, we have the coupling, we have our UART, and then this is some microcontroller related stuff. So I think I'll put connectors down here, and then is MCU. Yes. Don't want to put anything else there.
Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush.
Boom, connecting time. So we need... If I make the temperature humidity sensor on a connector, like external as well, that means I can use any I2C sensor and just make a tiny daughter board or buy a tiny daughter board. And that will also thermally insulate it. So I think I'm going to do that because I don't know. I guess I could go check the efficiency of this. I don't have it open. No, I don't have it open. Yeah, I'm imagining like at 5 watts, this tiny mains power supply does get a bit warm or hot. And you can try to isolate thermal sensors by doing thermal cutouts and stuff, which will help a bit, not a whole lot, in my experience anyways, at least not on small boards. I guess if I made a huge board, it like the distance would just help as well, but yeah. So I think I will put it on a connector. So what is I2C on this? Do I want to break out all of these? No. Not really. Let's go and find... This should be in KiCAD already. Pin definitions. I2C. Actually, we should really check if ESP Home has some sort of restrictions on which I2C it can use. It actually uses a super, or whatever that's called, too. That's why I couldn't control it. So it defaults to 21 and 22. I'm guessing you can... Yeah, so ESP32 has 2. I'll break out both buses, I guess. In case I end up with 2 sensors with the same address that can't be changed for some reason. I can't imagine I will, but hey, nice to have it. So what is that? It is an 04 for the serial as well. Yeah, 04 01X04. Generic. I will go for a so pin 1 on these is always square, and I like to keep that as ground, so I'll flip it around Y. What is it? I always forget the memory thing. Oh, yeah. Okay. So maybe this changed because I think I used to remember it as flip it around Y, but now it's flip it along Y. Maybe I'm probably just misremembering. Yeah, if you hit Y, it'll flip it across the x-axis, which I guess would be along the y-axis. Anyways. I would like to have that bag on. And I will actually put a SMD. Maybe, yeah, they call it solid. Okay. And I will do a 3 bridge between 1, 2. So that I can select for I'll leave the ITC ones hooked up to 3.3 volts standard. I could actually write or in the same amount of characters as that, but oh well, I like that. Man, this was a lot of extra work for nothing. And then we need the 2 UARTs as well. And I will leave those at 5 volts. Like that.
Started to fall, and where were you? know you're falling too, grabbing the wind, cutting my
On my so say it with hope and you were sure I couldn't agree that we were meant to be, but our love is what they talk about in movies. Our love is what they talk about, yeah, we were wild and free, and you know everything about me. So wild and free, and you know everything about me. 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 You know everything about me.
So this design isn't big enough that I am using hierarchical sheets, because I can fit all of this on an A4, as you can see. If I had more complicated stuff, like if it was just battery powered, I would make a sheet just for the power management, but it isn't. If I wanted to be really anal, I'll put ESP protection on these two. I could swap this to a 2SC6, and then I'd have 4 pins, and then I could do 3 of those chips, and then I'd have, well, yeah, enough. Basically, it would take a 4SC6 version for each sub-block here. And then it only takes the 2 for the USB, but just to keep one SKU, that would also be swapped. But I'm not going to do that. I am too lazy. I am, however, going to add a reset button. Right here. I'm going to take this. Nope. This. Do that, and then I can do that. I do not like that it... This does not need to be visible. I don't like that, like, sometimes it'll let you mirror the component and the text will follow on the other side, but sometimes it won't. Well, it's fine. Cool. What do we need to annotate? Sorry, assign. All the resistors, I think. Yeah, and some capacitors. My 22 microfarad caps are... I hate myself. I have not shown you anything I've been doing. Let me go over it quickly. This stream is useless now, because that was up there for a long time, I think. Damn it. Anyways, yeah, just this. UART connectors default to 5 volts, because that's what my sensors that run UART run. But I do have the option to cut that and swap to 3.3 volts. It's the opposite for I to C. Yeah. I don't know if you saw me doing this. I think that was before I brought up the data sheet. And then I added a reset button and I organized all of it. So I have USB to UART here. I have auto reset here, ESD protection here. I was talking about adding ESD protection to these by going for the 4-pin, well, the 4 signal version of this, and then having 3 of them, one for this block because there's 4 signals, and one for this block, and then just to keep them the same one up here as well. Not gonna do that. It's a tiny chip. I probably should Yeah, I'll... I don't want to. Let's do it. Let's do this properly. USB LC6 4SC.
Yeah, I'm on my way home.
Let's see if I can find another
Around Manhattan, they're all laughing.
another playlist from non-copyright songs.
Yeah, I'm driving in my car and seeing open, but I can't go down that road again. I'll smoke a cigarette, but will that help me forget you? Will that help me forget you? I just need to forget you. Oh, you.
Oh right, I should actually... Not sure I've done that.
I need to treat you better than that and make you feel like I did in the past. Oh, I will treat you better than that. I don't need to forget you. I need to treat you better than that and make you feel like I did it.
Let me just check something.
Oh, I will treat you better than that. I don't need to forget you.
Here you go. Alright, description updated. Actually crediting NCS, even though I do have the credits in the bottom right corner at all times. But now it's also in the description. Because that is technically what they ask for in the terms. And that is fair. Right, let's see if they have another playlist. I'm not a huge fan of that one. This is just called Infinity, whatever that means. But yeah. Non-copyright song. Yes, so many different uses in Spotify called something in that regard, or playlist or whatever. Oh well, I think we are done with this layout. No, we are not. So I will go in the datasheet. I will not turn on the overlay because I will forget to turn it off. I will find the I2C pins. Actually, they were defined here. I will verify it, but yeah. 13 and 16 for A. Oh. Well, I guess I won't be breaking up both because I'm using one of them for UAD, so let's go check that just to make sure. What? Is this just a weird example, or is it for... Okay, I'll turn on Firefox. Pray to God that I... Or to pray to something that I remember. Yeah, this is a weird example. So this is not actually the... Okay, good thing. Good thing I happened to run into an issue with using those, and... Yeah. SDA... So what do they say the default to? 21 and 22. Let's find out what Expressive calls them. Maybe this is one of those chips where they can like remap it in chip. Like to different pins. Let me just look that up. Yeah, I guess so. Yeah, almost any pin to our HZ capabilities. Okay. Let's use the default ones just for A, and then two convenient ones for the other one. Which pins can you not use? They do not mention that. Which ones were they using in this example? 33 and 32. Nine and 8. I will change this when I start writing. And then it was 21 and 22, right? Yeah, let's just... I'm a dip. Did I not literally just... Yeah. There you go. Um, 18, 19, 21, 22, and it was 21, 22. Which are not that close, but okay, sure. Yes. I will probably stop streaming after this and do the layout tomorrow or later anyways, because it is 1:30 a.m. I will be using these pins here for I2C. I will just quickly check in the pin description that 18 and 19 can in fact be used, that there's not some special things. They don't have any asterisks, so they should be good. Yep, cool. I think that's it. Let me do the footprint association. Did I click the wrong thing? Maybe it's already open. It is. This is the footprint editor. Right, so my 22, my caps are 0805.
Oh, you tell me stories. You tuck me in.
You can't see the little preview window I have open, but yeah.
You leave, I call you right back to check for monsters in my streets. Yeah, high school was
I'll just do these hand solder. They're a bit nicer too. Well, hand solder.
with my mom. I'd fall asleep to
What do those are also 805, okay.
left emotional scars. Now I'm 21, a soul of 50 years. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. At 21, a soul of 50 years. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. At 21. At 21. I'm doing things that I shouldn't do. At 21. I'm just a kid. Oh, I'm doing things I shouldn't know from. Yeah, doing things I shouldn't do. At 21. Yeah, I play you my favorite songs on a car ride while you list me all the people that left you in your life. Oh, oh. And you smoke on your chair while I was trying to sleep. I smell the smoke in the air, but that was normal for me. I didn't know. I didn't know. But now I'm 21. A soul of 50 years. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. At 21. Feels like I'm 50. And now that you are gone, I'm doing things that I shouldn't know from. I'm doing things that I shouldn't do. At 21. At 21.
I wonder if they have one that is So what I want is I want the middle pin removed and just use the two outer pins. But I could also go for just one with wider pitch.
At 21.
It's down here.
At 21. I'm 21.
No, these are all. I mean, they're nice and wide pitch. So I need something that's 5.08, so this is 5 and 2. I don't think I can get these, so Wago tends to be pretty hard to source in low quantity. Let's check. Wago 236 for 2. Nope, not on awesome. So then it doesn't exist to me. I keep hitting escape, and I'm not what I want to actually hit. Alright, let's go for this one. Just fix that. Let's go for this one. Here, it's a generic. This one, the generic screw terminal. Well, technically it's a brand name one, but it fits with most generics ones I find. That is. I went through all the effort to add this Palcon UTC 16G. Turns out that this type C up here is a clone of the Palcon. So that was fun. I think I'll just use... Should I use GST? I'll use GST that is pitch compatible with normal 0.1 inch headers. So 2.45. Oh, they don't have that. I mean, I guess this would be mostly compatible. I'm not gonna get GST headers. I'm gonna do pin headers. Whatever. Yeah, I'm just gonna do that one. Oh. There we go. Save. What did I do? Oh, I hit escape. Yeah, I'm tired. Jumper. Like that one. And then for the resistors, we'll go all 603. For the switch, I have some. Whew, what would that be? Is it 6x6? It looks right. Sure. Apply. Okay. And I think that will be it. Let's go import the components in the layout just to look at them. So yeah, here's a crude footprint I made for the PTU. I will update this footprint so that it fits library convention, KiCAD library conventions, and I will upstream it. But yeah, for now it'll just be used. So don't actually want to show. Oops, show that. I do want to show that. Oops. Oh god damn it, now it started laying out. Okay, I will not touch traces. I'll try and group things. You know what? Oh. There. Left justification right above the pin. This line on the fabrication line. This is how I go about that. I will just actually edit this, because you can get them without the middle pin, and if you can't, you can remove it. Whoops. Save. There we go. Looks like I forgot to actually change the value of that. There you go. What? That's fine. That is because there's no pad 2 here anymore. I will not touch traces. I will not touch traces. I will not touch traces. This over here will be higher voltage, so I'm probably gonna extend this built-in keyboard sound, but I tried to match this as good as I could to the datasheet. I think this arc is wrong, but yeah. Cool, so these would be the outputs. Man, this is a lot smaller when it's not a schematic symbol, huh? This I will try to keep on the other end of the power supply. Man, this looks stupid. So this would be a SMC, so probably that we're going for, and this is an SMB. Oh well, we'll have the room.
Wish I were the same, making bad decisions, it should be
my right
name. I love playing with fire, it's my favorite, watch it by my whole house down, not feel a thing. One look in the mirror, don't like what I find. I know that somewhere in there there's
So 5 volt here, over to there. Probably gonna run ground through here. Fixed. No, he didn't steal any cars. Damn. Yep, those are the middle pins. Oh, burn shit. Oh no, it's dangerous. Yeah, that's why I usually turn off the fab layer. Not bad. Funky. Ugh. KiCAD. Let's give that a name so it's easy to follow along. So this should be TXT. Whoops, that was not the right one. TXT. RXT. Pretty sure I don't want it to be a an interrobang. There we go. Well, let me just go on the front silk and use the default sizes for that. Yeah, it's a lot smaller. I think I'll try and group these. Okay, so then they should move together. Yep, nice. set up. But
Now my homies acting like I owe 'em, done extending out my arm. Made a lot of money from my poems. Been around it, now they say I'm on. I can finally say
man, I'm not good at streaming, huh?
20,000 on a bus down, a bus down. I'm on my way up, going up now, and I ain't never gonna touch down. Mine's on, I can't turn it off. Late nights and I'm turning up. Hate life, then I learn to love. Down and out, now I'm way above. I always knew I had it, now I'm living out my dreams. Treat that money like an addict, it's a habit. I'm a fiend, feeling that rush. Rocket ready to launch. Hands up, ready and gone. Been waiting too long. Trust on plenty, that's wrong. Old me's dead and that's gone. Thank God I'm headstrong. I don't wanna wake up in a doubt that I show 'em everything I'm about. I ain't never going out. I ain't never getting for no clout. Now I'm sitting pretty on the cloud. I'm say I'm up now. I'm up now. 20,000
Keep 1 millimeter away from the edge. And 2 holes. Yeah. Yeah, let's try that. If it becomes a problem, we can adjust it. Minimum through hole. Yeah. Not sure about this annual, but whatever. Ugh.
One look, the heat is rising, and I've been cold for so long. One touch and we're igniting, setting fire to
Yeah, I'm gonna
you know these flames ain't
group this roughly, and then nothing else.
crumbling to the ground. Don't think
Man, that is big.
now, 'cause baby our love is gonna burn down.
I have changed my mind. It will.
This building is crumbling to the ground. Don't think I wanna stop it now, 'cause baby our love is gonna burn it down.
Oh, that is huge. Am I remembering wrong? Is SMA the smaller one? It is, isn't it? Yeah, I'm being a doofus. Okay, so we probably want to go for an SMB one. Definitely don't want to go for an SMC. As you might be able to tell, I do not use diodes that often. No, I'm used to deselecting with escape and fusion.
You know these flames ain't going down. This building is crumbling to the ground. Don't think that we can stop it now, 'cause baby our love is gonna burn down. You know these flames ain't going down. This building is
That makes a bit more sense.
don't think I wanna stop it now, 'cause baby our love is gonna burn it down.
Let's keep it here so that this can like stick out through some sort of 3D printed support. from like here. Yeah, keeps the copper like right there. Well, I guess the copper goes out there. We'll leave it there for now. I want that on this side. No, I want it on the other side. It's easy to cut there. Yep. What am I? Weird. Oh, it's because it's a group. Right, okay. Oh. Pin one up. Yeah, pin one towards pin one makes sense. And I'm leaving 3 visible dots. Nice. I actually like having the X there, so I'll go and
Drip. Yeah, I've been running and running to keep it 100. It's all that I wanted, but lately I don't get the stomach. The higher the summit, the harder the plummet. They know me all over this planet. Oh, darling, if I had bought you flowers, would you still be here by my side? Yeah, I thought.
because I don't know now. Like, yeah, I will definitely not block any pins that I'll be routing. That's nice. Oh, no, leave that there. Power supply. That needs a capacitor, which would be C1. Then we need all of the decoupling, which is 2, 3, 4, 5, 6, 7, 8. Nice. 2, 3, 4. So. Need 6 and 3. And 8. So to match the schematic, 2, 3, and 4 for the ESP. So in KiCAD, if you have this slight misalignment, it's usually because you actually grab the pad instead of like the middle point, or like didn't grab the same thing anyways when you moved them. I tried to tend to try and grab the anchor. Yeah. So what was it saying? 2, 3, 4. Let's get the smaller, which will be higher frequency content, closer to the chip, because that'll be, well, yeah, inductance of traces will matter more. That's over here, okay. This is one of the cases where I probably actually do want to move it by the pad, because I'm trying to align the pads. And this is like a module, so I want to stay away from it a bit. Yep, there you go. I will... Wow, I can just really waste a lot of pins here, huh? This will go probably on a via underneath or something. Okay, and then the rest of these are for this. 5 and 6 go to one pair, which would be 6 and 7. Six and 7 to ground. So I'm gonna drop a BM. Yeah. Let's give this net a name. Ah, reset, okay. Let's not give that a name. Sure. Bit of a bummer. Guess we won't be doing much on this side. And then there's... Man, I really don't think I need to do like double bypassing here. The other ones would be C7 and C8. Here they are. I'm no good for you, so I drive around Manhattan. They're all laughing. Oh, I'm tragic. Yeah, I'm driving. This is stupid. Yeah, no, I won't be doing. I'll try. I really don't want to do it, but A, I'm streaming, so it feels like I'm holding myself to a high standard then, and B, I feel like if I don't, the chip's gonna laugh at me and invent some sort of issue. So this goes to pin 5. Yeah, no. Like, I'll just be moving the caps further away from the chip, which also does not help. So this is also wrong. God damn it. And I'll bring out the power from over here. I'll still bring the diode down here because it'll make it easier with the case to sign if there's nothing tall right next to the case edge. Because then I can like route the power out this way and do it from the other one as well. Ooh. Oh, well, I keep saying funky, it's probably not the right word for it, but hey. Nope, it does not want to collaborate. Right, I actually usually put those out here, so I might mess with my power already a bit. So that'll go here. Guess I could do like a drop and then still bring out power this way. We'll try. This is my auto reset. Nope, this is my. Right, I was gonna do proper ESD. I'm not gonna do that. Right.
How does it feel to breathe when you're dead? They never seen you out of your head. Cut to the bone, it's broken up. How
close to the connector because the USD event will be on the cable or in the connector. So you want to dissipate it as close to the connector as possible, because otherwise you might not really be saving anything. Basically think of ESD events as a wave that goes through the conductors, and you can think of ESD protection devices as holes that try and suck in that wave. But they're not like, it's not like if the wave hits it, it's gone. It's like trying to suck it in. So there's like a radius around the ESD devices. Like this is a intuition about it. So like there's a region or circle around the ESD device that is not quite safe because the wave can kind of get there before it gets pulled back into the hole. So yeah, so that's the intuition. You want to keep it as close to the connector as possible. No wonder the 1 amp SMC diode we found was good. Yeah, I think I'll continue this tomorrow. I'll still do stream. But yeah, we will fit this stuff down below here. I wonder if that's a... Yeah, we'll fit this stuff below here and we'll get it all wired up, and depending on when I do a stream tomorrow, if I do a stream tomorrow or later, whatever, and I happen to pick up the stream, depending on when on the day I do it and how long laying out takes, I don't think it will take a lot longer. I might also start doing some case design for it. But yeah, thank you for watching, and I hope it was useful, even though I sometimes rather often forgot to remove the Fireflux overlay.